Hi, I am Lubna from ITK. Elliptic curves are trending. However, some products still rely on RSA. But why is that? In this video, we'll try to answer this question and the following two questions. Why elliptic curves are used in cryptography, and what are the advantages and disadvantages of using elliptic curve in cryptography? As we just said, elliptic curves are trending and are often used in cryptography and considered as the best solution for asymmetric cryptography. But usually when we said asymmetric cryptography, we think directly to RSA and not ECC. Why is that? Let's go together through a comparison between these two cryptosystems, RSA and ECC, and see the difference between them. As you see here in this following table, which is the least recommended key sizes for RSA and ECC for different security levels, starting from the 80-bit security level to 256 security level. The key size of RSA are bigger than the key sizes for ECC. As an example, let's take the security level 128 bits. For this, the RSA key sizes is equal to 3072 bits. However, it is only 256 bits for ECC. So here we can easily remark that the key sizes for RSA for the security level is equal to 12 times the key sizes of ECC. If you don't know how a number of 3072 bits looks like, here is an example. It is really a huge number that could be considered as a public key for RSA. However, here is a number of 256 bits, which could also be considered as a public key for elliptic curve cryptography. And this one is much more smaller since it is equal around 8.3% of the key sizes of RSA 3072 bits. So the small key sizes of elliptic curve make them very attractive for implementation in a restricted environment. When we say a restricted environment, we can think about an ECU, we can think about smart cards, an HSM, and many other products. So, elliptic curve cryptography offers a low CPU consumption and also a low memory usage. So for you, if you have a product, you want to secure it, and you have to use asymmetric cryptography, your product does not have enough space memory. In this case, the unique and best solution is to consider elliptic curve cryptography and not RSA, because even you cannot implement RSA in this case. So here it is really a very important advantage of ECC, the small key sizes. But the question that we can ask here, why are many products now their security is based on RSA and not ECC, not yet changed to ECC? Of course, there are many reasons behind it. Here in this video, we'll try to tell you some of them. The first thing that RSA in some industries, company banks, they already have implemented RSA. So they have the basic implementation. They don't need to change everything because it costs a lot of money. So for them, they don't need to change their infrastructure. They have just to follow the least key recommendation. So for example, for 128 bits, they have to follow the key sizes of 3072 bits, and everything is fine for them, even if they know that ECC is better. But not only this, changing the infrastructure is not enough, because these companies, at least they need to provide to their developers, engineers, at least high-level trainings regarding elliptic curve cryptography in general and their implementation. So in this case, they have to invest not only money, but money plus time, which they want to avoid. And another important thing to say here is that even to implement some cryptosystems regarding elliptic curve or to understanding elliptic curve is not an easy problem, because there are a lot of mathematical background behind it. As for example, the equation form, which form of Weierstrass, Montgomery, Edward, the group law, the arithmetic over Fines field, the hashing from to a cyclic group, the system coordinates, the Jacobian projective or affine coordinates, and which algorithm we have to use for the scalar multiplication. So there are a lot of things to do. That's why all this stuff can be considered as a blocker or considered as an obstacle for companies to change from RSA to ECC. But not only this. Another reason is that RSA was patented only from 1983 to 2000s. Since 2000s, it's for free, unlike ECC, which are patented. So we are again giving a financial reason behind choosing RSA and not ECC. But not only this, there is another disadvantage regarding elliptic curve cryptography. But this time is not only related to elliptic curve cryptography, but also to RSA. RSA and elliptic curve cryptography, as we know, they are used for asymmetric cryptography based on a pair of keys. And their security is based on hard mathematical problems. For RSA, for example, the factorization of a huge number. For ECC is the discrete logarithm problem. And these cryptosystems that are based on hard mathematical problems don't resist against post-quantum attacks. Here, the same thing for ECC and RSA. And this can be a disadvantage against using elliptic curve because maybe in the future they will not be used anymore. So, but this is related not only to ECC, to RSA also, and to all asymmetric cryptosystems. Now we gave you some advantage of using elliptic curves and disadvantage, and the answer to the question why some industries are still using RSA. And now we want to conclude our video by checking the take-home messages. Before that, let's tell you a small story about elliptic curve. Elliptic curve were used thousands of years ago for mathematical domain, only for that. But the first time that it is used in cryptography was in 1985. And there are two mathematicians, Victor Miller and Neal Colpitts, together at the same time, but independently the one to the other, they presented two cryptosystems based on elliptic curve. And since that date, elliptic curve were interest a lot of mathematicians and cryptographers, and a lot of research are done there. 20 years later, end of 2004, beginning of 2005, elliptic curve entered to the public domain, and then they are considered as the key of asymmetric cryptography because of their nice properties. What are their nice properties? The first take-home messages is that the small key sizes of elliptic curve make them very appealing for devices with limited storage and limited processing power, which are becoming increasingly common in the IoT. As an example, elliptic curve, the small key sizes of elliptic curve offers a speeder SSL handshakes with a strong security, if of course we compare with RSA. Not only this, you know, we have at least one product with us which its security is based on elliptic curve cryptography. Yes, all of us. As an examples, the European biometric passport, the Austrian card, the German ID card, the new German health insurance card, and all cryptocurrency, their security is in part is based on elliptic curve cryptography as Bitcoin, Zcash, Ethereum, and others. This is the first take-home message. The second one, yes, even if the implementation of elliptic curve is considered very, very hard, and the mathematical background behind it is hard also. But your developers, engineers, they don't need to start from scratch. They can just use the open source implementation that are available online of ECC and use them for your products. And if they need to understand the important stuff regarding elliptic curve and their implementation, we as ITK, we can provide support for this. Third take-home message is that if you don't want to use a patented elliptic curve, you can generate your own elliptic curve. Yes, it is possible. Once you generated your elliptic curve, you will study the different kind of attacks on this elliptic curve. There are many attacks, For example, you will verify polar law attack, MOV attack, baby step, genius step attacks, side channel attacks, subgroup attacks, and lot of others. And once you have a balance between the efficiency and security, you can use your own elliptic curve. We are aware about such a work is very hard to generate a secure elliptic curve that can be used in practice, but we as ITK, again, we can provide you such a support. The last take-home messages for our video is the following. Yes, unfortunately, elliptic curve cryptography don't resist against post-quantum attacks. The same thing for RSA. But the important thing to know here is that based on elliptic curve, isogeny are defined, which are just a non-constant function defined on an elliptic curve. And cryptosystems based on isogeny resist against this kind of attacks. So in the end, any knowledge about elliptic curve will be used later. Thanks a lot for you. And if you need to know more details about elliptic curve, the mathematical structure, anything regarding the implementation, the algorithms, we can provide you such other videos regarding this implementation. So just add a comment. Thanks a lot.